Hello, one. Good morning, dear authors and invited guests. Welcome to Technical Session 5C, 6C. Myself, Karthik Bharadwaj, and this session would be moderated by me on behalf of Global Knowledge Research Foundation and GR Solistic LLP. It's my great pleasure to welcome you to the 8th World Conference on Smart Trend in Systems, Security and Sustainability, World S4 2024, London, UK. The 8th edition of the conference is being organized in a hybrid mode. The physical event was organized yesterday in London, UK, and the virtual event is being held through Zoom from 24 to 26 July 2024. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for their presentation and 3 minutes for question and answer round. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected with us till the end. If you have any query or update, then you can write it to me in the chat box. So before moving forward, I would like to introduce you with today's session chair, Dr. Samiksha Shukla. Dr. Samiksha Shukla is Director and Professor, School of Data Science, Symbiosis University of Applied Science, Indore, India. Dr. Samiksha Shukla, her research interest includes computation security, artificial intelligence, machine learning, data science, and big data. Her core expertise lies in computational security, artificial intelligence, and healthcare related projects. She has 16 years of academic and research experience. She is a reviewer for the Indus Science Journal, Springer Nature International Journal of System Assurance Engineering and Management, and IEEE and ACM conferences. Ma'am, I request you to please address our participants.
Good afternoon, all. So it is my pleasure to be with you all for this paper presentation. Hope to listen to you and learn what are the advancement you have in your research. Looking forward to have a healthy and informative session.
Thank you, ma'am. Now I would love to extend my welcome towards our next session chair, Professor Gradul Ethik. Professor Gradul Ethik has served in education and research organization in Turkey, US, Singapore, Kuwait, and UAE, as well as an on-site reviewer for 50 plus industrial R&D projects. He holds 15 plus years of in-depth research projects and teaching experience in business and data analytics, as well as 25 plus years of exposure to analytics and artificial intelligence. His research interests include supply chain management, data mining, and application of industrial engineering and operational research. Sir, I request you to please address our participants. Okay, sir is facing some network issue. Let's move towards the first presentation of the day. For the first presentation, I would like to call Pont and Paul for the paper title Applying Convolutional Neural Network with Candlestick Image to Predict Corn Price Movement. Presenter, you may proceed with your presentation. Okay, let's move towards the next presentation. For the next presentation, I would like to call Manuela for the paper title Enhancing Health Data Utilization with Business Analytics in Academic Research. Presenter, you can proceed with your presentation.
Hello, can I share my screen?
Yes, ma'am. You can share your screen now.
Okay, thank you. Okay. Hello, everyone. My name is Manuela, and I'm a teacher. I'm a teacher in and research at the Faculty of Economics of Coimbra. I'm sorry, but I want to leave it there. Okay. My presentation today will be about NCLT data utilization with business analytics. This presentation discusses how business analytics can help extract useful information from health data for academic research. This is my summary for today. Implementing business analytics technique in the health sector presents several challenges. One of the key challenges we face is collecting and integrating data from diverse sources and multiple systems. This process is both complex and time-consuming. Another key challenge is ensuring data quality and accuracy. This is essential to prevent inaccurate decision-making. The importance of data quality cannot be underestimated because data quality defines the level of accessibility and consistency needed to conduct effective data analysis. Privacy and cybersecurity are also critical. It is crucial to ensure the preservation of privacy and manage cybersecurity issues. In the study, the focus lies in enlightening the importance of data analysis for academic research with business analytics. In the Portuguese health system, healthcare is provided in several institutions, such as hospital and regional health administration. At the time of the study, the regional health administration services were organized and coordinated at the regional level. And primary care services are delivered in local unit and healthcare center. In this study, we used data from the regional health administration center of Portugal. The focus was on enlightening the importance of data analysis for academic research using business analytics. This study involved structuring time series of monthly health data prescribed in a health center unit and distributed by the regional health administration. The period for data analysis was between 2009 and 2022. And in this context, automated systems play a key role in structuring and analyzing health data. The regional health administration consisted of 9 sub-regions, each of them organized by local units. The regional health administration includes 78 municipalities and it's cover approximately 23,700 square kilometers with an estimated population of around 1.6 million residents. In this context, between 2009 and 2022, the institution generated a large volume of data that needed to be structured for analysis and research purposes. The objective were to optimize data for 2 studies. One focused on medications consumption and another on the use of statins. The strategy for integrating, processing, structuring the data are shown in the figure. We adopted the Kimball methodology. The process begins with the health data input phase, progress over several stages that generate data and conclude in several outputs. The 2 databases in the figure are data lake and the data warehouse. The first store the unprocessed raw data, and the second processed and structured data. We used algorithms created on Excel VBA to aggregate the file and store them in the database. All the files were stored in a data lake, and the data was organized in structured table. The data lake function as a database that ensures the original data stay unchanged. Unstructured and semi-structured data were cleaned and normalized. We used the ETL process for data processing, normalization, and for data cleaning. We fixed a specific problem and inconsistency through data transformation and then moved the data to the data warehouse. We used business analytics to get valuable information, and finally, we used Excel to visualize, manipulate, and analyze the data and to generate output files and results. The data initially provided by the LT organization included different formats, such as CSV, TXT, and Excel files. The data sets include details on medication, consumption, statins, related disease, and patient information. The dataset covered the period from 2009 and 2022. Some data were organized into annual records of specific type of disease, while others were organized by health center. The data were extracted from the LT organization, which is divided in 9 health unit centers. In the medication consumption study, we merge data from two separated datasets. The first dataset related to disease associated with statins involved 214 files in CSV, TXT, and Excel formats. The second dataset comprised patient information, involved 205 files. The data was organized into annual files, which corresponding to a specific disease type. In total, we aggregated 490 files in different formats and data structures. After the ETL process, we were left with approximately 177,000 records for future use. In the statin study, files was organized by LT unit center. We was 868 files. First, we organized the dataset into annual records. All the files comprise a total of approximately 28 million records. I'm sorry. And after the ETL process, we were left with around 232,000 records for future use. The data processing involved creating the tables to store information with the relational database. This process includes the use of the data mining techniques and methods to ensure data quality. The process of transforming data included exploring the data to identify and correct any inconsistency in the data. This step was crucial in ensuring that the data was accurate and reliable for future analysis. The table provides an overview of these problems and their solution. It details both the inconsistency encountered and the action taken to solve them. Only after data processing was completed, the data was loaded into the data warehouse. This study resulted in the creation of a model designed to facilitate the extraction of knowledge from health data. The model enables to analyze and interpretation of health-related information. The goal is to simplify the process of data acquisition and to provide information for academic and health professionals. The aggregation of health data was found to be important to conduct different analysis for academic purposes. In summary, and to finish, the integration of TL process, data mining techniques, and business analytics offer comprehensive method and approach for analyzing health data, and this combination simplifies the extraction of knowledge and information. Thank you very much.
Thank you, ma'am. Samiksha, ma'am, do you have any question?
Hello.
Yes, ma'am, you're
Yes.
audible.
Yes.
Yeah. So I have a few questions, ma'am. It was nice presentation. I just want to clarify on two things. One is you have collected data sets. So what were the parameters which you have considered in that data set?
We collect all the data the health center disponibilized us. And after that, with the criteria of the research, the team research, we select the data. Basically, we collect all the data the health center disponibilized, and after that, we select the data.
No, I just want to know what were the parameters like in the data set. You would have taken patient ID, patient name, or disease or symptoms.
We collect the location. We collect the type of the disease. We collect some results of some analysis of the patient, but we don't collect the information about the patient individually. We don't collect this information, and we collect because it was several data sets we need to organize. So we use a lot of parameters.
Okay, okay. So another thing is like for experiment, what was the configuration of the device which you used?
The healthy centers give us the data in different format, as I say. And we with Excel we organize all the files. It is very easy for the research because the team research is a team research in pharmacy. So for them it's very difficult to use technology. So with Excel they can organize the files, all the files we received. And after that, we create the database in SQL, and we link the Excel with the SQL. We create some rules to make easy to use the data for the team research.
Okay, okay. Thank you so much. It was a nice presentation, ma'am.
Thank you, thank you.
Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I would like to call Shaw Jakhan for the paper title Forecasting the Production Indicators of a Construction and Installation Company using the example of Press 12 JSC. Presenter, you may proceed with your presentation.
Yes, good afternoon. Hello to everyone. Okay, let me introduce my paper, our paper, because we wrote this paper not one person, but I have also co-authors. So the title is Forecasting the Production Indicators of a construction and installation company. An example of Uzbekistan's construction company, Press 12 joint stock company. So let me start with introduction. At first, I want to introduce Press 12 company. It's a well-known construction and installation company in Uzbekistan, has a rich history. And the study addresses the following question: what are main factors determining the production efficiency of the company, and how do workforce characteristics such as number of employees and level of education affect a company's profitability? And also, what are the prospects for our company for the next 4 years. We also predicted for the next 4 years. So literature review, methodology, and which this study uses a combination of econometric modeling approaches to study production efficiency and forecast the financial performance of the company. The analysis uses historical company data as well as ordinary least square OLC and VAR vector after regression models. This part provides an explanation of data collected methodology, description of the variables included in the study, and you can ask what variables. So then it is here we can see the independent variable. The first one, it is the dependent variable. In the case of it is net profit. We mentioned it like Y. And the measure in million of Sum. Sum it's national currency of Uzbekistan. And the next indicators, they are independent variables. The first, covered employees, a number of covered employees, X1. And the next one, it is number of employees with secondary education. And the third variable, number of employees with higher education. And the model is used to estimate correlation between the dependent variable, net income, and independent variables. So here we can see the results. The first step, it was the regression results. Here we can see interception, X1, X secondary education more affected. Here we can see to our Y. So the next VAR model results. Here we can see the VAR model results show net income exhibits a significant element of after regression with varying positive and negative coefficient of different time lags, suggesting complex and dynamic behavior. Covered employees have a noticeable but different impact on net income, resulting in just a minute, sorry. Covered employees, but different impact, resulting in a decrease in the first deferral and an increase in the second deferment. The impact of higher education on net income is significant, exhibiting both positive and negative effect over different time periods. And this demonstrates the complex correlation between education, attainment, and profitability. So the next prediction, here we can see the prediction net profit of our company 2024 from 2024. Here we can see they will increase significantly from 28,000 till 33,000. So here we can see the forecast assume a sequential increase in net income on the normal business scenario, while the pessimistic and optimistic scenarios offer a range of potential outcomes depending on changes in economic condition and internal company performance. So, conclusion. On our regression study demonstrated a favorable relationship between the number of insured individuals and employees with a high school education and net income. Conversely, an increase in number of college educated workers has a negative impact on profitability, likely due to an increase in associated costs. So the VAR model produced results that demonstrated the dynamic relationship between net income and workforce characteristics over time. These results indicated the presence of large autoregressive components and complex interaction between variables. The validated VAR model produced net income estimated for the next period. Forecast indicators steady growth under a business scenarios. And I think it's enough. Thank you for attention.
Thank you, sir. I request Samiksha ma'am. Do you have any questions?
I have a question. Has there been similar studies in other countries?
Thank you. Yes. Also, we saw in our literature review also other countries similar. Just a minute. Here we can see the use of dynamic econometric analysis learned in European countries also, such as Spain, France, and also in Central Asia, our neighbor countries like Kazakhstan, Kyrgyzstan, Russia, and others. So we choose that variables, which variables have to affect to financial stability of construction company. After choosing the variables, we did an example of our object.
Okay, thank you.
Thank you so much.
Thank you, Gajul sir. Thank you, sir. Now we are moving towards our next presentation of the day. For the next presentation, I would like to call Samaruddin Mahmudov for the paper title Maximizing Customer Traffic Strategies for Augmenting National Income and Ensuring Economic Equilibrium, an analysis of Uzbekistan through econometric simulation. Presenter, you may proceed with your presentation.
Do you listen to me?
Yes, sir. Now you're audible.
And methodology. This study uses an econometric approach to analyze the impact of customs tariff policy on national income and economic stability in Uzbekistan. The main methodological framework used is RDL model, which is well suited for studying both short-term and long-term relations between economic variables. The following section details data sources, variable selection, econometric model specification, and steps taken to ensure the robustness of the analysis. The data used in the study was obtained from the State Statistics Committee of Uzbekistan and the Custom Committee of Uzbekistan. The data set includes quarterly observation from 2013, 14, and 2023. Variables Y, dependent variable custom duties, total revenue received from customs tariffs, independent variable custom values, X1, declared value of imported goods, X2, independent variable import value, the total volume of import subject to tariffs, X3, independent variable total incentives, total benefit, various incentives and incentives applied to imports. X4, independent variables, exchange rate between Uzbek sum and major foreign currency. Result of discussion, figure 1, scatter plot between dependent and independent variables. The data presented in figure 1 show a strong correlation between dependent and independent variables, reflecting clear density conditions. Density-based grouping of data points highlights significant correlations, indicating the tendency of these points to align and cluster along axis, demonstrating the robustness of relationships. consist alignment of the diagonal segments of all independent variable in the graph increases. Confidence in the assumptions of normally. Moreover, change in the exchange rate over the years indicate some irregular and distribution. The table 1, correlation matrix and dependent and independent variables. The result indicate a strong and significant correlation between the dependent variable and all influencing factors. In addition, the correlation metric present in table 1 confirms absence of multicollinearity between the dependent variable and the independent variables. Additional, given the p-value is less than 0.05, correlation coefficient demonstrates their significance. Table 2 unit root results for dependent and independent variables. Based on the data present in table, the unit root test produces the following statistical values for the dependent variables: this value, and independent variables this value. These results indicate that both dependent and independent variables reached stationary findings supported by McKinnon minimum value. Achieving stationarity in time series analysis is critical because it simplifies the modeling process and improves the reliability of statistical inferences. Moreover, a positive unit root test suggests the need for differentiate and alternative transformation to ensure stationarity of the data. In addition, after initial integration of the dependent and independent variables, the unit root test value demonstrated stationarity. Regression equation results for the RDL 101 model. You can see these formula models, our RDL models. And conclusion, based on the analysis and finding regards in the interaction between customs duties, customs value, import duties, general benefits, and exchange rates within the national customs systems, the following recommendation were developing using the RDL 10101 model. In the national customs system, a 1% increasing in custom value result in 0.88% increase in customs duties in the long run. This indicates a direct correlation between the value of goods passing through custom and associated fees. A custom value is increasing to so do fees, reflecting the direct relation between customs value and duties. In the national economy, an increased import value by 1% leads to an increase in customs duties by 45%. This suggests that as import volume increases, revenue from customs duties increase proportionally, demonstrating a positive correlation between import volume and custom duties. And under the national custom system, an increased general benefits by 1% leads to a decrease in custom duties by 0.42%. This inverse relationship indicates that as the incentives provided by the customs system increase, the duties correlated decreases. This is likely due to policies or regulation aimed at optimizing incentives without significant bartering trade with high tariffs. In a domestic economy, 1% increase in the exchange rate results in 0.93% increase in customs duties. This shows that exchange rate fluctuations affect custom duties with higher rates leading to higher fees. This is due to the impact of changes in the exchange rate on the custom of imported goods, which subsequently affects the amount of custom duties. In addition, these analytical results provide valuable information about the dynamic relations between key factors and customs duties, which within national customs systems. These results help researchers and stakeholders effectively understand and manage revenue flows and trade dynamics. Thank you for attention.
Thank you, sir.
Sir, could you
Well,
please
sir,
highlight the key parameters of your finding? Am I audible?
yes, ma'am, you're audible
Hello.
to us.
Yes. Sir, could you please tell me the key parameters of your final result, the findings which you have got? You were talking about dependent and independent variable. So could you please tell us what were independent variables? What was dependent variable?
We have dependent variables. Independent variables, we have customs duties, total revenue received from customs tariffs. Independent variable, custom value, declared value of imported goods. Second independent variable, import volume, the total volume of imports subject to tariffs. And third independent variable, we have total incentives, various incentives and incentives applied to imports. And fourth independent variable, exchange rate between Uzbek soons currencies.
Okay, thank you. Thank you. It was nice presentation.
Thank you, ma'am. Gudal, sir, do you have any questions?
Hello, I have a question. So what is the tangible suggestion that you would be making for, let's say, Uzbekistan government based on your research results? Thank you so much.
Sir.
It's okay if the voice is not available. We can communicate later. No worries. It's okay. Thank you.
Okay, sir. Now we are moving towards the next presentation of the day. For the next presentation, I would like to call Alexei for the paper title Model-Based Cyber-Physical Multi-Agent System for Autonomous Resource Management with Event Lifecycle Time Metrics. Presenter, you can proceed with your presentation.
Yes, greetings to everybody. I am here.
Greetings, sir.
You can see my screen. It is.
Yes, sir. The screen is visible to us.
The full screen of the presentation, yes?
Yes, sir. The full screen is visible to us.
Okay, so yes, welcome to all of the colleagues. My name is Alexei Tobachinsky. I am affiliated with Samara Federal Research Scientific Center, city Samara in Russia, and I'm here to present our paper, which is called Model-Based Cyber-Physical Multi-Agent Systems for Autonomous Resource Management with Event Lifecycle Time Metrics. So in the paper, in the paper, we will discuss a method to estimate proposed architecture and functionality of the cyber-physical system which includes multi-agent system for calculation of the resource management and the implementation and application of such a cyber-physical system in a digital twin of plant. And the broccoli is taken as a culture example. So in our proposal, the cyber-physical multi-agent system consists of these key major systems, which are listed on the slide. The first one is a digital twin, which is a model of the real object, which is used to simulate and make decisions for the environment. A multi-agent system, where agents with standalone aims and functions, and the agents are able to operate with the multi-agent environment. And event lifecycle metrics, which estimate the adaptivity of decision-making systems based on the multi-agent system. So the architecture of our proposed cyber-physical system is listed here. The key components are the following: the ontology and the knowledge bases, which are used to formalize the knowledge about the domain knowledge of the digital twin domain, and for resource planning domain. Event log as well, which stacks the events from the real world, which could be predicted or as well as unpredicted, actually. And agent environment, which consists of asynchronous program agents operating in the virtual market for negotiations between themselves to estimate the optimal solution, near to optimal solution. Virtual agent skin, where actually agents are operating and calculating the current state and forecasting the future state of the agents and the environment and each one object. And also sensors and execution drives on the real layer, which harvest data from the real system. For example, it will be a field in the agricultural farm, for example, and operate in the real world based on the decisions made by the cyber-physical system. Yes, go. There are known a lot of applications of cyber-physical multi-agent systems in different spheres of industry in the whole world. And for example, for manufacturing, and they are used to integrate the flexible manufacture systems and solutions. Also, there is a concept RAMI 4.0, which consists of 7 hierarchy levels and 6 life cycle levels. And also for agriculture, these cyber-physical multi-agent systems are also in a high level of prosperous. And for example, they implemented as smart agricultural systems for resource management tasks in the farms. And the key functions are crop monitoring, or maybe soil monitoring, field monitoring, or maybe climate, and so on and so on. As well as for monitoring, they can be used for prediction, of course. So event lifecycle is described here, actually. So for each state of the multi-agent system, we have actually 9 steps, which are described here. Major metrics, not actually metrics, but the steps of the events. So on the first step, event is occurred, then event needs to be identified, yes. Then event is processing by the multi-agent system, and based on the new event processment, the resources are rescheduling. So based on the near to optimum solution between all of the agents, where they compare their satisfaction and penalties, they create the new plan. After the new plan created, all the agents contains feedbacks. Excuse me. They keeps the feedback and adapt to the feedback for the new plan. Then they execute the solution and finishing the execution. After the real solution made by the multi-agent system is executed, the solution again gets the feedback from the system. So the key adaptivity metrics for these multi-agent systems are the following, two of them. Time of transition between the different system states, how much time was taken to proceed to these 9 steps and to get the new optimal solution of the system, and the flexibility to the unpredicted events. For example, how many events could be occurred not to improve the time of the transition. On this second part of my presentation, I would like to describe the digital twin of plant solution based on the proposed method which was proposed above. And the architecture of digital twin of plant actually is similar to the architecture of other systems which are created based on this method. So architecture of digital twin of plant consists of the knowledge bases of crop production and primarily of the crops, cultures, so varieties and variety models, which formalize the different rules for each variety because they're different. And also in the knowledge base, the scheme, which is used to describe all the agent world and the real world in particular is stored. Database on the ontological level, it is storing the description of ontologies and models, and the relation database is storing the object from the real world to make the system working, of course. Multi-agent system in this digital twin of plant implements the following functionalities: forecasts the crop production process in the duration of the stages of the crop, for example. Forecast of the crop parameters of each stage, because in the ontological model, each crop is characterized by a finite quantity of the parameters, and on the different stages, they are characterized with the different parameters. Which are linked to the phenology of the crop, and planning of the agricultural measures and farm resources based on the crop forecast, which also made in this multi-agent system. And of course, on the bottom level, on the highest level, actually, user interface is also developed to help user to work with the digital twin of plant. On this slide, you can see the multi-agent architecture of the digital twin. So on the left side of the slide, you can see the agent of the external environment for the crop, where the crops on the fields are negotiating between each other for the resources of the farm, because the fields are finite. The resources of the farm, like fertilizing, pesticides, and machinery as well, drones and so on, they also finite. But crops, they have their own aim to improve the yield, to get the highest yield. So based on the negotiation with the external environment, we can get the near to optimal solution based on the finite quantity of the resources. And on the right side of the slide, you can see the architecture of the inside world, internal crops world, how the solution of the crop simulation is made. So in our proposal, each one crop could be characterized with a number of a sequence of stages, which all are represented with their agents. And each one agent is represented by the limbs or part agents.
Sorry to interrupt, sir, but you have 2 minutes to conclude.
Excuse me, okay, I got you. So you can see the right part of the slide, and I hope the architecture could be seen there. So here you can see a slide of the ontological model which was put based on the broccoli production process, which represents the rules of broccoli growth. And on this slide, the most important one, we can see how the digital crop of broccoli was grown, and the real crop of broccoli was grown compared to each other. So on the date of sowing, we have created digital twins of broccolis and the real ones. And based on each one step of the climate forecast, of the soil forecast, and other events which occurred with the real crop, we have got them in the digital twin of this crop. And finally, we have seen all the forecasts and calculations of the parameters which are specific for broccoli. And here you can see the comparison between the real observations and the crop digital twin calculations. So actually, here are the key results. Like a method was proposed, and this method of calculation of unpredictable events was implemented in the digital twin of broccoli, and the method was estimated in this implementation. Okay, I was short. Yes, thank you so much.
Thank you, sir. Ethics, sir, do you have any question?
I
I have a quick question. Hello?
Yes, sir.
Yeah.
Yes, sir, you are
Yes,
audible.
Yeah, thank you for the interesting research. Just was wondering, I mean, you selected as the case study broccoli, and what are your prospects that, you know, the same methodology may be applied to other crops, and maybe especially other crops operating under different conditions, different, growing, let's say, procedures. You know, how generalizable is your methodology, do you believe? And what is your support for your opinion? Thank you.
Yes, very valuable question. Thank you for that. Of course, the broccoli crop was taken to considerate because it is like an ordinary greenhouse crop, and it could be grown in the totally controlled environment where you can operate with the temperature, with the moisture, humidity, and so on. And also, we have actually our major crop for the digital twin is wheat. We are developing digital twin of winter wheat and spring wheat as well. And I also could maybe show you the results of simulation of wheat, because in Russia we have major fields covered with the wheat, but it is out of the this presentation, unfortunately, because here we wanted to discuss broccoli in particular. But also you can see a lot of our publications which are introduce digital twin of wheat there. And also one of our last publications, we are there trying to enlarge our ontological model to different crops, and as well the prototypes, so alpha versions of the digital twin for soybean, for sunflower, and some other crops which are used in the wheat crop cycle. There are three cultures in summary. They also developed there. So our ontological model of the crop production allows us to create the digital twins of plants for the other crops. And it just needed some data and some researches a little bit.
Thank you so much.
But it could be scaled. It could be scaled. Yes, you can look our publications. Thank you, of course.
Sure. Thank you so much, Dr. Tabachinsky. Thank you.
Thank you, sir. Samiksha ma'am, do you have any questions?
No, I don't have any question. It was a great presentation. All the best for your next research work.
Thank you, of course.
Thank you, ma'am. Thank you, sir. Now we are moving towards the next presentation. I would like to call Tulkin for the paper titled The Effect of Inflation and Credit Interest Rates on Investment Activities in Emerging Economies, a case study of Uzbekistan. Presenter, you may proceed with your presentation. I think so. He's facing some issues. Okay. Now we move towards the next presentation of the day. For the next presentation, I would like to call Quantum Paul for the paper title Applying Convolution Neural Network with Candlestick Image to Predict Corn Price Movement. Presenter, you may proceed with your presentation. I think so. They are facing some network issues. It's okay. We are moving toward the closing remark of the today's session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for your support during the 8th version and all the previous 7 versions of the conference. We'll be happy to have you in the 9th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of World S4 2024. I would love to extend our gratitude towards our session chair, Dr. Samiksha, for chairing the session. This is a token of appreciation from the team of World S4 2024 and Global Knowledge Research Foundation and partners. Ma'am, kindly address our participants.
Thank you so much. It was nice listening to all the presentation. Looking forward to upcoming conference with Global Research Foundation. Thank you for my co-reviewer for this session chair. Even his input were very nice. I think it will be helping the presenters to improve upon and come up with a better presentation in next version of the conference. Thank you.
Thank you, ma'am, for your valuable presence. Now, I would love to extend my gratitude towards our next session chair of the state, Dr. Radul Etek, for chairing the session. A token of appreciation to the chair on behalf of Team World S4 2024 and Global Knowledge Research Foundation and partners. Sir, kindly address our participants. I think so, sir is facing some network issues. It's okay. Now, I request everyone to please turn on their cameras for a quick snapshot of the virtual conference. I request everyone to please turn on their cameras for a quick snapshot of the virtual conference. Thank you everyone for your valuable presence and contribution. Happy to see you in 2025. Thank you everyone. Take care. Stay safe. Bye-bye.
Thank you. Bye-bye.
Thank you everyone. Thank you.
Thank you.
Thank you, ma'am.
Goodbye. Thank you.
Thank you, sir.